All right, welcome back. It's kind of hard for me to teach in a quiet voice a little bit because I like being loud. I like getting excited. So we're going to do hypothesis testing, or no, we're going to do interval estimation, population mean, sorry, interval estimation, population mean. We're going to do an interval estimation for the population mean where we have the population standard deviation known. I'm not doing caffeine today either. So maybe I could use a little bit of that, but too much caffeine for me is no bueno. I can only do it like once or twice a week. All right, so I'm gonna say, can you please give me a simple problem to solve myself to help reinforce for me the concept of interval estimation in statistics where the population mean for the population mean where the population standard deviation is known. All right, we'll go with that. And we'll say, instead of can you, I'll just say please. We'll be more managerial here. Instead of request, we're going to say you need to do this. And please do it. Here's a simple problem for you to solve. A company wants to estimate the average weight of a product. They take a random sample of 50 products. So I'm going to get my piece of paper. It's Grandparents' Day. I didn't know there was such a thing. I guess they want us to buy more Hallmark cards. And I'm just looking at the notes over here from last time. Let's get rid of those. And a company wants to estimate the average weight of a product. They take a random sample of 50 products. So N is equal to 50, random sample. And the average weight of the sample in grams is 120. So my X bar, which is my sample mean, is equal to 120. The population standard deviation, so pop standard deviation, is equal to 8 grams. Construct a 95% confidence level, and I love this slide here, right? So here, this slide. So confidence level could also be known as the confidence coefficient. So I think we got to include this slide here. We're just going to grab all of that. I wonder if I could copy the whole slide. Just copy it here, and then come over here, and put it here. And yeah, cool, that entire match style, keep original style. That's fine, keep original style. And we'll do, I guess we'll just leave that here, and we will do highlight all of that, and we'll make it like that. And then we'll add another little note here, and we'll say, this is a reminder of important terms, and we'll highlight all of that, and we'll center it, and then we could rotate it. Rotate me, is that it? That's my rotate. And we'll put that here, and then we'll make it like, we could do the bucket, and we could do like pink. It's gonna be so bright. I like this blue here, right there, that one. That maybe is good blue, right there. And then we'll make it bold, just so we can read it a little bit more. And maybe rotate just a touch more. And put it here. I like that, okay. That works. That's a little bit not the right spot. That's a better spot. And should we make this a little bit smaller? There we go. All right. I know this is a little bit slow, but so it goes. And this is something we need, right? We need to see this. So back to our problem. So confidence level, which could also be called confidence coefficient. We're done with that one. So we're going to call this here confidence level, confidence coefficient. And we're doing this so that we learn the terms. And the confidence level is 95%. 95%. All right. Construct a 95% confidence interval for the population mean weight of the product. How do we do this? I gotta make sure I'm still recording. Cool, I am. And there's here's that, and then here's this. And so I think it already solved it for us, but I'm not looking, you know, to see what it solved. But when we have n and we have the sample mean and we have the population standard deviation and we have the confidence level, confidence coefficient, there are some formulas. And so we're looking for the known case here. And so here's the known case. So now we're looking for the formulas. And you don't need to memorize the formulas. You just have to know which formula to go find and then use it. And so I'm just looking through here to see like where is my formula, and that looks kind of like a formula. And we have the sample mean, and then we have the population standard deviation, and then we have the sample size, and then we're going to have a z-score, which comes from our confidence coefficient. And what we want to do here is we want to, company wants, give us a 95% confidence interval for the population mean weight of the product. And so this is interval estimation for the population mean, where this is good. So let's go ahead and just calculate this and see what we come up with. So we'll take that formula here and we'll use it. And I guess we'll just put our stuff like that. So we're gonna have 120. We're gonna have plus or minus. And then our z-score is from our confidence level. And so if you remember, 95% confidence, this will be 95%. And then we'll have our alpha, and our alpha is known as the level of significance, right? And it'll be 1 minus the confidence level. And so the alpha is going to be 0.05. And we have 0.05, but that 0.05 is this and this combined. So if we take 0.05 and divide it by 2, which is why you have alpha divided by 2, right, we're going to get 0.025. And with 0.025, if we go to our z-table, because it's a normal distribution, 0.025, we go to our z-table, and we're looking for 0.025, right? 0.025, 1 minus 0.025, because here, our z-table shows us all the data from the point over to the left. All the data from the point over to the left. So from this point here over to the left, this is 0.025, so that means this is 0.975. And so 0.975 is right here, it's 1.96. And after you've done statistics long enough, you'll be like 95% confidence level. The z-score on that is 1.96. 1.96, right? Right there, 1.96. So 1.9 and 0.06, 1.96 right there. So 0.975 is 1.96, so we're going to have 1.96. And that's how many standard deviations. Remember, z is the number of standard deviations from the mean. So it's how many standard deviations from the mean it is to that point. Well, that's what we want, this quantity of standard deviations. We want that quantity of standard deviations. But how much, and this is all the margin of error, this is the plus or minus some amount. So we want this quantity of standard deviations, but how much is a standard deviation? So this is the quantity, well, this is the quantity that we want, and this is, how many of those we want. So this is called the standard error, just this part here. And so this is the quantity of standard deviations, and you could think of this as the standard deviations, and standard error is the standard deviations for this thing here. And so to calculate that, we need sigma over square root of n. So we're going to go multiplied by, and we need sigma, population standard deviation, divided by, I said multiplied earlier, but it's going to be divided by, and n is going to be that, so we're going to do square root of 50. And so when we calculate this, and to calculate it, I guess I will go to spreadsheets, and it's going to be spreadsheets for chapter 9, so we'll create a new folder, 09 module 9, and we'll come in here and we'll open it up and we'll go new and do a new spreadsheet. See, it's not quite the same as when I'm all amped up on caffeine and I'm talking loud. And now we're going to calculate this. So we're going to have, I guess to calculate it, I need to put this on one side, and then I need to put this on the other side. And just make sure I'm still recording. All good. All right. So we're going to have 8 square root of 50. So can I do this all in one formula? We'll go to 200%. And I've got to do the square root. So we'll do that here. And we'll do square root 50. This is going to be equal to square root of 50. And that's what that is, okay? And so now we're going to have equals 1.96 times 8 divided by that. Is that right? 1.96 times that, and it doesn't like it. 1.96, I think I have to put in, I actually have to put in the multiplication symbol. There we go. And so now we're going to see that our interval estimation is 120 plus or minus 2.22. So we're going to have equals 120 minus that 2 1 equals 120 plus that. So that's what we're looking at here. So I'm going to copy this and put it over here and paste it in, and I will do a little dash between the two. Okay, so that's our answer. And let's go to ChatGPT. I guess we just leave that one on the left. That's pretty good on the left. We'll go to ChatGPT. And cool. And says you can use the following formula to calculate the confidence interval for the population mean when the population standard deviation is known. And so we have X bar, the sample mean, and CI is our confidence interval, and our Z-score, how many, what quantity of standard deviations from the mean is there, and then the size of the standard deviation. This is the margin of error. It's the plus or minus part, and then this is the standard error right here. And so here, all that is Z-score corresponding to the confidence interval for 95%. It's 1.96. They really do the work here for you. And population standard deviation is the population standard deviation and is the sample size. Once you try solving it, feel free to share your steps. I can review them for you. And so we'll just copy all this and paste this in there and see what ChatGPT does with that. And so, you know, I could even provide, you know, something like, oh, I should have said, great job. You've applied the formula correctly. To break it down, sample mean, population standard deviation, sample size, Z-score, margin of error. So 1.96 times that is 2.217. So the confidence interval is that. This means you're 95% confident that the true population mean lies between 117.78 grams and 122.22 grams. Well done. Does this concept feel clear now? That was great. You're amazing. Thank you. That was great. You're amazing. You're amazing. Thank you. And let's see what it says. Oh, you're very welcome, Todd. That's so nice. I'm so glad you found it helpful. If you ever need more help, feel free to reach out. You're doing awesome. Keep up the great work. It's amazing. It's truly amazing. Pray. And we'll do that. And give it a little thank you sign. See what it does with that. Just one emoji. You're welcome. Take care and good luck with your studies. It's so incredible, man. All right, so that's the solution for this first review.